Frequencies 16 Hz, 100 Hz, 250 Hz, 500 megahertz, 600, 1 gigahertz, 1.6 to 2 gigahertz. It is a way of connecting computers together in a local area network. Advantages is simplicity, ease of maintenance, ability to incorporate new technologies and reliability. It has low cost of installation and easy to upgrade. Here 4 types of cabling are commonly used in Ethernet. So one is a 10 base 5, 10 base 2, 10 base T, 10 base F, that is bus thick. Here bus thick coaxial, bus thin coaxial, star UTP, star fiber. Transmission devices for Ethernet. Repeater, you can see here we are sending the distorted input signal, we get a output pulse output. Okay, so once it receives a signal, that is amplified to eliminate any distortion and forwarded to the output port. So this is the repeater. It works a physical layer of the OSI or OSI/ISO reference model. So next is a hub. So here multiple output. Okay, so multi-port repeater which links multiple Ethernet devices. Hub passes the incoming signal to all devices connected to it. And bridge, it has 2 ports, operates in the data link layer. It transmits the incoming frame only if the channel to its destination is free or the frame is broadcast frame. What it will do, it has 2 ports and operates in the data link layer. Okay, this is a physical layer. It operates in the data link layer. It transmits the incoming frame only if the channel to its destination is free or frame is broadcast frame. Transmits the incoming frame if the channel to its destination is free or the frame is broadcast frame. Each port on a bridge supports a full duplex operation. Next is a switch. Message processor, message queues, that is input output. Okay, this is a switch. Multi-port bridge, unlike a hub, a switch will not broadcast frames across the entire network. It will send the frame to the intended ports. Router, it is used as a gateway between LAN and WAN. Router is used as a gateway between the LAN and WAN. It makes an intelligent decision on how to route the traffic. It is used a gateway between the LAN and WAN. It makes an intelligent decision on how to route the traffic. Wireless LAN components, that is one is a station. Here station, any devices that communicates like notebook, computer or mobile phone that supports Wi-Fi. Okay, any device that communicates like notebook, computer or mobile phone that supports Wi-Fi. Okay, first is a station. Collection of stations forming an ADHOC network is called an independent basis service set, that is IBSS, independent basis service set. Points, that is when AP is present in a network, it allows one station to communicate with another through it. Here twice the bandwidth is required. AP makes the system scalable and allow wired connection to other networks. When AP is present in the network, the collection of stations is called infrastructure BSS. Next is a distribution system. It interconnects multiple infrastructure BSS through their AP. Set of infrastructure BSS is called extended service set. So you can observe access point, This is the access point infrastructure DSS. This is a distribution system. So set of so it interconnects multiple infrastructure DSS, that is called as a distribution system. Next is a Bluetooth. Wireless communication. It is also wireless LAN technology used to communicate. It is used to connect a mobile or fixed devices using low power, short distance radio transmission. Distance range is 150 meter and two network architectures, that is Piconet and Scatternet. You can observe the Piconet, and this is the Piconet and this is the Scatternet. Here it is a master node and these are the slave node. These are the slave node. Okay, this is the master node. So here master node and slave node, it is mixed. So master or slave node, it is called as master bridge. Okay, and here you can observe this is a slave node, it is a slave bridge. Here it is separate master node is there. Okay, so this is the Piconet, this is the Scatternet. Here Piconet, it is a Bluetooth network consisting of a master device and up to 7 slave devices. You can observe here 1, 2, 3, 4, 5, 6, 7. 7 slave nodes are there. More devices can exist but not able to communicate concurrently. A device in a parked state can move to active state. A device in a parked state can move to active state if the number of slaves in the Piconet falls below 7. Okay, if it is below 7, then from the parked state to it will move to active state. Piconets that are interconnected is called Scatternet. Here two types of Bluetooth links are there. One is asynchronous connection link and synchronous connection link. For synchronous connection link, used timely deliver is more important than error-free deliver. In asynchronous connection oriented connection link, here used error-free delivery is more important than time delivery. In asynchronous, error-free delivery is more important. In synchronous, time delivery is more important. And 6LO WPN, it is the most popular and it is a low power consumption, high flexibility in networking and low cost also. Here Zigbee can be a full function device or reduced function device. FFT can operate in 3 modes: coordinator, router and an end device. But here RFD can operate only one, that is an end device. Once again I repeat, Zigbee is a low power consumption, most popular and low power consumption, flexibility and low cost. So here it is a FFD and RFD. FFD will operate in 3 modes, that is coordinator, router and end device. RFD operate an end device. Zigbee network, 3 types: star, mesh, cluster. Star, okay, this is a star connection and this is a mesh and this is a cluster. So here 6LO WPAN. So these are the architecture: physical, MAC, adaptation layer, IPv6LO WPN upper layer. This physical and MAC we call it as IEEE 802.15.4. And RFD in 6LO WPN wants to send a data packet to an IP enabled device outside the 6LO WPN domain. It first sends the packet to an FFD in the same WPAN. An FFD which acts as a router in 6LO WPAN will forward the data packet to hop by hop to the 6LO PAN gateway. 6LO PAN with IPv6 domain will then forward the packet to destination IP enabled device by using the IP address. So you can observe this is a 6LO PAN. Here smart meters are used. Here this smart meter, concentrator and smart appliances, smart sockets and possible communication path. So 6LO WPAN, first what it will do, RFD in 6LO WPAN that wants to send a data packet to IP enabled device, okay, outside the domain. So it will first send the packet to the FFD in the same WPAN. What FFD will do? FFD, which acts as a router, that will forward the data packet hop by hop to the gateway. Router to gateway. Next, with 6LO WPN with the IPv6 domain will then forward the packet to the destination IP enabled device by using a IP address. Next, WiMAX. This is a worldwide interoperability for microwave access. So you can see the base station, relay station, mobile station. This is a mobile station and similar, okay, it is. So both fixed and mobile connectivity using a technique called orthogonal frequency division multiple access. Both fixed and mobile connectivity using a technique called orthogonal frequency division multiple access. Orthogonal frequency division multiple access. This is for 50 km, 75 Mbps and 75 Mbps data rates.